Everybody's huge. There was someone who's there and yeah, so it wasn't a game. Are y'all like that? No, he's happy. Don't say that. You all right? Just hiding. I don't know. Biggest shop in the biggest cheapest. I feel 60. I think you got somehow I did like 50,000 damage to the body or something. It's like I so that's like full boat words. Bring your W. Yeah. I'm really I'm glad I see Dr. But I'm just sure you started probably for sure. What you do? You don't.
The technology over here on that podium has sort of died away. So all technology seems to have died away. The only thing I got working is the camera. So there's camera and audio. Okay. Good grief. Let's try that back. Oh, there we go. Okay, so we're gonna go old style. So, I mean, the network was bad. If you bring up, if you're not here, there still will be a stream, but it's just gonna be from about, let's see, my hand's about from right here. So I need to kind of keep away from that area of the board. I don't know here. This is a strange way to do it. Let's see how far it goes on the other end. It goes to the second line. So I can go to about right here. Okay. So technology, you think it's going to work, and then it doesn't. So we talked for a minute about vectors, and then he has a section in here where he does vector addition like this, where he has a vector A, and then he has some vector B, and then what he wants to do is add these. Now, there's two ways to do this. What he starts off with is the old standard where you create a parallelogram, and essentially it's like taking B and copying it over here, and taking A and copying it here. But I don't even know if he puts the arrowheads there if he doesn't. But then your addition would be this. Now, when he starts going through that, there are two laws that are kind of beneficial for you. And I'll just use this area, and I know it'll pick up this area. So you have the law of sines and, or, I'll say and, cosines. So if you just had some weird triangle like this, then in here your little letters were the angles, and the big letters are the distances. So it's kind of hard to do, so I'm going to put a little thing here to indicate that that's capital and that's small. And this is what you'll find about the sines is it's kind of, okay, so I'm going to do either or. So you've got sine, and you're obviously not going to take the sine of the lengths. So these are lengths. So you're not going to take the sines of the length, but you'll take the sine of the angles in there. I guess the last one is this. But you can also flip it over. I mean, it doesn't have to be that way. In other words, if the ratio is one thing, you can flip the whole thing over. I'm not sure the benefit of one over the other, except maybe you just don't feel like dividing. I mean, and it's kind of up to you. Now, if I make a mistake up here, just correct me. I mean, I'm prone to falling asleep in the middle of the lecture. So this is straightforward, but in any particular one of these, you can see what you're trying to do. And let's just take it for instance. I'll say sine A over A equals the sine of B over B. Over B. Now, if this equation was going to be useful, the first thing is you have to know three things. You have to either know A, capital A, and the B would have to be known in order to get you somewhere. Or maybe you know A, you know little b, and you know this. And if you start looking at this, you'll start to see a pattern here. And I guess I can use it. Okay, so I'll use this and erase it. So you either know, first thing you're going to know is you're going to know an angle length pair. You're going to have to know an angle length pair. The second thing is an either or. Then you're going to have to know this to find that or that to find this. If you know that angle length pair, you know this one, then you can find that one. Well, if you have this and this together, you can add it up and find B because they all add up to 180. In other words, A plus B plus, these are all the little ones, equal 180, depending on, you know, whether you like pi or, but it should, I should, degree up there. So, what you'll need to know in order to do sines, law of sines, is an angle length pair somewhere for you to, and then you'll have to know something else somewhere on there. So keep that in mind, and then look at what, I'm trying to repeat this so it doesn't look, if I was using the thing, I could just do a copy and paste, but I'm not, because the technology is dead or almost dying. Law of cosines, to use it, it's a little bit different. Now, in the book, he writes one, but there are three of them. And now, you've seen this before, and I think about it like this. If it's 90 degrees, and this is B, and this is C, and this is A, you're all happy. But cosine of the angle between these two, which is a B and a C, which will be the A. B and the C, wait, B and the C, which is the A. Now, look at this one, and look at this, and look at that, and what you'll realize is 90 degrees, this will be a little d, and this will be a little c. But what's the cosine of 90? If you look at the plot, cosine starts up here, heads down to 0, heads to here, from there, and then back here. So it's 360, what's it, 270, 180, and 90. So this law of cosine reduces down for these things that are 90 degrees. So this is kind of an equation that always works. And then this is the one you're used to seeing, but this is the one in which the 90 degrees set there. So this is not anything new. It's just these extra terms got stuck on there because this might not be 90. And if it's not 90, then you have a way of dealing with it. But you can also work this thing around. Cosine of a little b, or, and I don't know why, but here, I'll just complete it out. So what is it? Okay, so this one could have multiple issues here. But the first thing you see is usually when somebody's saying something with an equation and there's one value on the left-hand side, that's usually what they're focused on. So in order to find A, this length, you need to know this length and the angle between them. So if I knew the little a, the big B, and the big C, I could find this A. Now, look over here and see, can you do that over here? If you knew this, and this, and this, you're still dead in the water. So, and here's what I mean. I don't know if this purple marker works. If you knew C, and you knew B, and you knew A, nothing you can do. You're just kind of dead. However, once you found that this A from this, you can start the town now because you've got that, and then you could work off this to get this, and then once you got that, you can test it with this, and they all have to add it to 180, so there's a lot of things you can do. So just remember that the reason you have the law of sines and the law of cosines is two different arrangements can be attacked this way. So when you're looking at this, and this is an issue that you can easily make a mistake. I've made mistakes. Everybody makes mistakes. But let's say we had a situation where, say, the length of A was maybe, I don't know, 10. If that's 10, maybe B the way I've got it drawn. Maybe that's 7. And I don't know, this might look like maybe 10 degrees. And I don't know, that doesn't quite look like it's 30, so I'm gonna say it's 20. So let's say, okay, so I've got those. Now that's just the baseline. Now what I've got to do is be able to get this in an organization such that I can find the information that might be asked for. Usually in the book, what they'll do is they'll ask for, I want to know the length of the resultant vector and the angle from the horizon or, you know, the horizontal or whatever. So he might want to know, say this distance. So when you start laying this out, you look at it, you have two triangles to work off of. You have this upper one, or you have the lower one. But it turns out they're mirror of each other. So it's up to you. One person might pick this one, the other one might pick that one. I don't really know. But then you start looking at this thing. Okay, and I did not do, let me try to see if I can touch it up a little bit, make it look a little bit better. Here's what I'm gonna try to do. I guess if I'm gonna not use this, maybe I'll try to find, oh, that's locked there, that's not, oh, here's a good straight edge. So, I mean, I don't see any particular reason anyone would take that. It's pretty much useless, so if I just went over here and did about like that, that looks about right, and then just kind of slide it up here, that looks a little bit better. No, that's kind of tilted down. I don't know, you could probably see better than I can. And I would be apt to look at the camera up here and say that, but the camera aspect ratio is weird. So this one is real, it takes the board, which is really long, and squishes it. I don't know what the stream is gonna look like, except there's gonna be this really ugly guy walking back and forth across it. But, so, how do you lay this out? Well, what I'll do is I'll extract part of it. I don't know why, but gosh, I wish. This is where I've relied so much on this stuff for the last year, so it's going to be harder for me. So here, I'll draw a line out here. I'll draw a line here. I know that's 10. Didn't I say that's 10? So that's 10, even though over here it looks bigger than it does there. Now that's not 20. So this passes the line here, and this is some alpha. However, if I'm careful, I could draw this line across to the top, and this is not looking very much to scale because, okay, so if I drew that line and just pushed it all the way up here, then those would be opposing and this would be 20. That really looks awful. So how do you get the angles out of here? Because what this, it's going to either be, okay, well, wait a minute. Let me go ahead and put these lengths up here. So the A is this one, and it's 10. And the B is this one, and it's 7. So it immediately looks like, so I don't know this one, so let's just call this C. We call this little c. And I guess if I'm calling this A and this B, little a, can you tell me what any one of these angles are? Can you tell me what C might be?
Square root of 149.
What? Square root of 149. Okay. So, tell me how you got that. I'm just, this, okay, before you start, I will say this. Okay. There are, I'm not one of them, but there, I have noticed over the years I've done this, there's certain people that see things.
I'm new, I know.
Oh, okay. That see things that you, it takes you a little bit to get used to being able to see them, like where the angles are. Then there are some people like me, I look at it for a minute, I'm like, I'd rather break it in components, which is what happens in the next section. Because, believe it or not, mathematics is a great crutch. If you want to survive a long, long time, just use math as a crutch instead of just trying to look at stuff, interpret stuff. It does work well. This is one area that takes certain people have that ability to see things. It depends on how much caffeine I have as to whether I can, and I've only taken one drink, so.
I've had none, so my mind's off.
It's okay. Well, okay, so if I drew this down, okay. There's a couple ways you could do it. I'm not sure what they are. Anybody see it? Okay, do it.
Little a is 30 degrees. Reason being is if I take that XY axis, I have a 10-degree angle on the top, a 20-degree angle on the bottom, and 2 angles of alpha. Since those are similar triangles, therefore 60 is equal to 2 alpha, alpha is equal to, 60 is equal to 2 alpha, alpha is equal to 30, so A is equal to 30. Unless I've got something jacked up.
Well, here's what. We'll try a couple of things. How about we try a couple of things? So I don't know what this is. I'm going to try this. Okay, so I'm touching this with C here. I'm touching this. This is 90 degrees. Touching that, that's 10. What's 90 minus 10? Is that 80? It's 80. So you can tell I haven't had much caffeine at all. So you got an angle here of 80. Now, if I draw this across here, if that's 20, this got to be 20. So now I've got a line coming out here. That's all great. I may have found that 80 and it may not be of any use to me at all. But it's just a matter of just start doing stuff. I got a line comes up here, touches this vertical line. This is 20, that's 20. So now the question is, what's this angle?
Plus the 20.
Well, if I drew a line there, yeah, I think you're right. So you draw a line here, these are continual, so it's 180. So to get 100, I said, it said it's 100, you said 100, and then I go to write something totally different.
Or you stack them zeros.
Yeah, I just stack them on top. So then you get 100. And so then you got another one, so my guess it's around 120. Now what we'll do is we'll check this with the other method in a minute. Because, okay, this is another rule of thumb. If you got the time and you're working in a real job, and a lot of times if you have the time in a real job, you figure out how to make it. They're going to make you work overtime anyway. So you might as well do something, you know. So what we'll do is work this problem one way, then we'll go to the next section, we'll work it the other way. So I'm going to guess it's around 120. I'm not going to guarantee anything. So let's start working for it. It's a 120. Now I got all this junk here, but I'm going to start relating it to all that over there. I'll come back and do this in a minute.
They can do C squared.
Yeah. So that's what I'm going to do. C squared equal to A squared plus B squared minus 2 and A and B and cosine of the one between them, which is the little c. So you get A squared. Help me out here. 10 squared. I think I can do that. I can't do that. That's over my head. Minus 2 times a cosine of 120. Okay. So if I want to know c, I can just take the square root of this. Anybody can tell me what that is? Because I could pull out my iPhone, but either my fingers are too big or the buttons are too small, because every time I hit it, it's a random, it's a 50-50 shot that I get the right buttons. I'm going to guess it's greater than 10, less than 17. Why would you say it's greater than 10 and less than 17? Well, first of all, you know it's less than 17, because if these two angles were perfectly out, C would be 17. It's got to be less than 17.
14.8.
What? 42.8?
14.8.
Oh, God, okay. Okay, that sounds about reasonable. Did that make sense, what I just said? If you take two angles, like if here's my angles, the length of my arm, the most I can get between these 2 points is the distance from here out to the other. I may not be making sense, but sometimes I realize humanity makes sense from the person who's talking, but like 99% of the time, the person listening either phases out or the person talking doesn't express themselves correctly. So if I'm not making sense, you need to just say, stop for a second. I don't understand what you're saying. Okay, now do we want to find the angle? I don't know. Well, yeah, let's find A. Okay, so now we have this. Now, I just want to go after A, because then I add A and 10 and take the 90 away from it and to get my angle there. So now I can go to the law of sines. Why? Because I know the sine of A over A equals to the sine of C, little c over C. Sorry, that C became a little too big. Here, we'll make it tiny. And so I can just fill it in. Here, I'm just going to be lazy and put in A is 10, C is 14.7, and A, oh, that's what we're looking for. Wait a minute, and this is 120. Did I do all that right? Okay, so what does A equal to? Okay, and my guess is 14. No, it's got to be, I have no idea. 30? Is it really 30?
Oh, I didn't positive, yes.
Oh, okay. We go again. 20. Do I hear 20? Do I hear 21, 21, 20? We have. Well, don't make me pull out my calculator, because I know I'll get it wrong.
26. 26, 41.
Yeah, probably. Because it's hard.
Okay, well, you know what? We'll have a way to check this.
Oh, that'd be Saturday. So then our Sunday.
Do you 0.43 before you did it?
Just. So sine of 120 divided by 14. Okay.
Maybe times 10, and then I decide.
Yeah, let's see.
Is that about right?
I don't know, nobody's checking.
Yeah, I got.
Okay, 35. I hear 35. I heard
So I
35.
got 35.
35. 35 going twice. When I say going twice or 3 times, that's how many people got it. You know? I'm just making stuff up over here. Okay, so we have a way to check it. I'm moving this out of the way so I can. Okay, so here's how I'm going to check it. Okay. Okay, I know that there is a section on dot products, and that section comes in like a week or 2. But I'm going to tell you, the way I do dot products is a lot. I use it more than not. And the way I look at it is a projection. So in other words, if I'm projecting A, and I'm going to tell you why I'm doing this, onto this, in other words, here's the sunlight. By the way, a dot product is nothing but a projection. It's like if sunlight's hitting a vector, it's projecting on the ground. What's the angle between them? In this case, it's 20 degrees. So this vector is nothing more than cosine of 20 degrees times the length of A. So that's the projection on the ground. Projection back, if you wanted to think that way, now, this will be in the I coordinate, the X coordinate. So here's what I'm doing now. Now, I'm gonna take these vectors and turn them into an A vector. I'm gonna say this is of length 10 cosine of 20. Now, yes, it's true, it's 10 sine of 20, J. However, I don't have to think too much. Okay, so here's the reason I don't have to think too much. Is often what happens inside your brain takes you where you need to go. Okay, so you were taught trig a particular way. I was taught a particular way too, but I forgot everything I was taught. And over the years, I figured out what's the easiest thing I could do to get somewhere. And what is something that is important. So what you were taught is, okay, what is this? We just said 20 degrees, right? And so we'll say this is H for hypotenuse, and we'll say this is X, and then Y. So you were always taught this, right? 20 is equal to what? That one over that one, or this one over that one? Is that that one? Okay. Okay, now, when you look at cosine, okay, now the way you have to think about that, I always just think of, if I want to project this onto here, I go through the cosine or whatever angle that is. Okay, and that's okay because I don't have to remember the rest. Because all I remember is now if I want to do the sine, to introduce the other one. So I don't ever remember but one. And I remember the other. Now if the sunlight's over here, and it's projecting this vector back to here, so this is a vector being projected on the wall. So imagine this being the ground and this being the wall. What's the angle between those two? 90 minus 20, right? Minus 20, what's that? 60? 70? Okay, 70, good. So here you go. I just think of it that way, is projection. The reason it's so nice now is this. If you have a vector A, you have a vector B, and you have some angle between them, guess what the dot product is? A dot. And we'll learn this later. The magnitude of A, magnitude of B, cosine of the angle between them. So in fact, now what you can do is you can say, well, what if the B vector was the I vector? In other words, what if B became some unit vector that was of length 1? Then by nature, this is what that would be. B back to A cosine of the angle between. And so what happens is this dot product can take that part of your brain that says, okay, is it opposite over hypotenuse, or wait, what's the other one? Adjacent. And then you're like, I don't want to think about that. I just want to look at the diagram and say, I'm going to put a sunlight here and project it through an angle. Cosine of 20 times that gives me that. I don't have to think that way. So when you see me up here, that's the way my brain is operating. So you're maybe operating from the adjacent and the hypotenuse and the adjacent. What's the other one? Opposite. I don't think that way. I think in dot products because dot products will carry you a lot further than adjacent and opposite and hypotenuse and all that sort of stuff. So that's why what I did is in my mind, I said, well, I'll project this vector to here. I'm going to project it back to here. So when I used the cosine, I knew the angle between it, so I projected it on the x-axis. I don't even think, because I know I see a cosine, I got to put a sine there. So that's the way I think. And so I'm not telling you how to think, because if I did, I'd be a politician. So I'm not one of those. So now I've got this. Okay, I'm going to project it. What's the quickest way? Me, I look at it and I see, oh, I know the angle between it. I'm going to project it. Wait a minute, what was B? 7. I'm going to project it through 10 degrees on that axis. So just like that, bam, I got it. I don't have to draw the thing and think, oh, opposite hypotenuse, oh God, So how much caffeine do I have to drink to do that? A whole thing. But this way I don't have to worry about it. I just project that vector back. Once I got the cosine, I'm like, I know the other one is the sine. Okay, so just repeat it, and I got that. And so I'm not saying that's the way, you need to go with what you think, and what you're used to, but if you just want to retrain your brain a little bit, I mean, sometimes that works. I don't know. There's so many things. There's this guy, really smart guy. I think he's at Carnegie Mellon. He makes these little 5-minute videos of how to think to do stuff. He had the quadratic equation up there, in a real weird way of doing the quadratic equation. And it took you a little bit, and you're like, because you're used to doing b squared minus, 4ac and all that stuff. Where, what is it? I don't know. And then over 2a, used to do it that way. He did it a totally different way. And what you find out by following his logic a couple of times, he was building each of these in a different way. And if you got to the point where you did it over and over, you could do it quicker his way, but you have to retrain the way you think. And there's a lot of that going on out there these days. So let's see if we can figure this out. Wow, this is pretty easy. How do you add two vectors? You've done this before, right? You just add the components, right? That's 10 cosine 20 plus 7 sine of, is that right? 10 degrees? Yeah. So here, I'm going to call this C. And plus 10 sine of 20 plus 7 cosine of 10. There's supposed to be an I right here. So let's see if we can get those. Can y'all do that? I mean, I guess I could try. But you know what? My fingers, to get the cosine out of my iPhone, I have to turn it sideways, and then definitely my fingers are too big for the buttons. So what is that? Okay, so here we're going to do this. We're going to say A, or, we don't know what A
It's
was.
not 26, I can tell you that much.
What is?
It's 25.8, or 35.8.
Oh, this one?
Yeah,
Oh, okay. So it's 35.8.
that looks like a 19 instead of 14.
Oh, did I? I don't write very good, so. Okay, so what we want to do, maybe I should write this bigger. I'll write it bigger and put it right here. 10 cosine of 20 plus 7 sine of 10 I plus 10 sine of 20 plus 7 cosine of 10. There's too many 10s and stuff in here. Did I do that? It says 7, 20, and 10. Oh man, it's too many digits. So what did y'all get? I'm going to sit down and tell y'all. Tell me. Then I'm going to. This is the cherry version because I was fooling myself thinking there were real cherries in there and it would be healthy. So what'd you get? Does it make sense what I'm doing?
Do you get 26 on the first one, and 13 on the second one?
So let's see. Man, that's going to be two numbers in a pretty close.
Sounds like you're right, because someone
Are we still working out?
You haven't been in.
Should I try it?
Haven't been playing ball.
I'm going to try it. I'll try to see what I can do. Now, the fact that I'm trying it doesn't mean anything. Okay.
I mean, added them together, I got 10 and 13, but
10 here?
yeah, 10.6 and 13.7. I don't know if it's right, because nobody tells me.
Well, we'll go with what you got so far. Well, let's do this. 10.6 squared plus 13.7. Why am I doing that? Does that equal that?
Oh, wait, oh, yeah, I didn't do it.
I got 10.3 instead of 13.
Right here?
10.2.
10
Thanks for
point
checking, guys. I waited 10 minutes for that, until I realized to put 3 seconds and stuff for some reason.
Okay, so, okay, let's try this. It's 10.3 and 10.6 squared. And this is where we go.
14.78.
All right. That's close enough to that. So now, see, we checked ourselves. Now let's try this. Okay. So we got a vector that's sitting here. And it's 10.6, and it's 10.3, and it's 14.78. What's that angle? To me, I would do cosine, because I would project this vector on the ground. Cosine of the question mark equal to 10.6 over 14.78. So the question mark would be arc cosine of 10.6 over 14.78. What'd you get for that? Did you get 35.8? Oh, you did.
Unless I did something.
Oh, well. Unless I did something wrong. It's gonna be, wait a minute, so if it's 45, it'll be the same.
Yeah, I got 44.
Okay, 44. Okay, so that, I would believe you. And that brings in something else that we did not do here. Okay, we found A, right?
Yeah, we found it.
And we know that's 10, but we've never found that.
No, yeah, it was pretty good, yeah.
So if we want to find that, and we believe this, let's say for a second we believe that. So this alpha would be 90 minus 35.8 minus 10. What's that number equal to?
44.
Does it really?
Yeah, right there.
It's like 44.2.
Okay,
Which
so,
is what we got, 44.2.
so we pretty much matched on both of those. So what we've done, so actually what we've done, there are two, okay, so what he has in the book, he goes on, I'm not looking at it, but okay, so first of all, I'm going to make a video for some people are not here and some people are, and I'm going to keep streaming. It's just unfortunately I'll be doing it this way because of the technology. But you'll have to get the book to do the problems. The book is not any different than a paper book, and I've taught this class for years, so I know what the section is. So what he does in the book, he starts off with this, the law of sines and cosines, and he does a lot. You're asking the question in your mind, and I've asked it many times, why? Why would you want to do that? If breaking into components is actually easier in a sense, it doesn't require you to work out this diagram to get that one angle. And there is one reason, there's only one reason I can figure out to do that. And he's got a couple of problems in it. I think I put one in there where you might have two vectors. And he'll ask the question, what's the maximum, here, I'll try to do a little bit better job. So he has this vector, and he has this other vector. And he says, what's the maximum that another vector, so you say this is F1, for example, some force, some other force 2, And then you're gonna add another force, F3. What's the minimum force that you would have to have in order for the resultant to be on the x-axis? To be going, so this is say F question mark. It's what you're doing, and this is F resultant. So the resultant vector of 3 forces pulled on some chain or something is the addition of the 3 forces. And he wants to know what's the minimum I can do to make it go, the resultant force to go along this x-axis, which I guess I should label. And there might end up being a case like that. Let's say you had something that you were pulling, some big object in the yard, bunch of lumber. Somebody's pulling it one way, you got a crane, pull it one way. But you actually want the lumber to go in a particular direction. So you might want to pull it in another direction, or pull the chain, you're pulling the winch this way, but you don't want it to come this way, you want it to go that way. But you don't want to put so much strain on whatever you're doing that you're going to break the cable. So you want this one to be the minimum. And it turns out, you know, if you draw a vector, these are the answers, and it's obvious that the minimum is 90 degrees from the resultant. So when you're seeing vectors in addition like this, where you're visually seeing them on the page, something like this, like you can get it like immediately, where somebody else will take these and say, well, I want the minimum. So let's add it up and create this obtuse, big equation, and I want to find the minimum, so let's take the derivative and set it equal to 0. Meantime, the other guy just drew the thing, drew 90 degrees, and he's out of the lumber yard telling him where to pull and how much to pull. So there's sometimes that, okay, this is, I'm annihilating my initial argument that said I use math as a crutch. Now I'm saying you need to be able to interpret things as well. But often you interpret things through the math, whether you know it or not. And so this is like math. I mean, drawing vectors on a page is math. I mean, you know. So what he did is he did all this. He did the laws and cosines and sines to get you through there. You know, you have 2 ways, 2 particular, you know, law of sines attacks one problem. Law of cosines attacks another problem. But you can use them together to quickly sweep through there. And then you come back to this, the next section, you say, well, we have components, and you spend like 2 whole sections writing this out. Oh, we have this in the x, and we have this in the y. We do all this, and we add vectors. Then they'll say, well, a vector, you know, 2 times a is equal to the vector multiply 2 times everything. Well, okay. You know, you're looking at it, and you're thinking, why are you writing it on the page? That makes perfect sense, you know. But he does that for completeness. So in essence, what I'm saying is we've covered quite a bit of material, actually. We'll go back next time. I'll try to get the book to open. I can't guarantee anything anymore. If it's technology and it's not up to date, it's going to fail. Because, you know, you update this and that doesn't work, and then pretty soon you just... That's why I started using Linux now, because so I guess I'm done. So there will still be streams. If you're sick or something like that, there'll still be a stream. You may have to now, when you're looking at it, you may have to make it full screen, because unfortunately, the video, if I show it's, you know, this is not the right aspect ratio. You get this much down here, and you get all the way to the top of the light. I'm going to look and see if it's good enough. I think I'm streaming out of here at high def, so I said it that way, but I have no idea what it is. We're running 49. I would turn the projector on and we could look at it, but the projector's not coming on. So, but you can draw it up on your phone if you wanted to. As a matter of fact, let's see. I had it a minute ago. And this will tell you also, there is a delay. So, and there is a chat feature, but there's a good chance I won't pay attention to it, so, cause I'll be busy up here. But maybe if one of you in class drew it up and somebody's chatting, you could see it and you could respond to them, that'd be fine. I mean, I don't know. You know, it seems to me like I did an online section, and if it's all online, it works okay. If it's all in class, it works okay. It's when you mix it and you have technology here and you're doing this and you're doing that, it's just a nightmare for me and for you. But at least I'll keep that going. The camera works. I think the audio comes out of the camera. There is an audio on the stream, obviously, and we'll just keep going like that. And then you need to get the textbook site and go work those problems. If you have trouble with them, let me know. You should get, I don't know how it works, but I made it so you get 5 tries on the homework, and then within each one, you can answer a question and you can say, let me check. I think it gives you 6 within that. So I think you should be okay. Even if you don't get a full 100, I mean, at least do it by the deadline, because then there's a deduction after that. And then the thing is I can look back, and if like 99% of the class didn't get this one problem or something, I could cover it and just say, okay, I'm gonna curve that one and throw that one away. I don't know that I can actually throw it away, but I can curve the grades of it. So that's all we got. Yeah.
Release the assignment again?
Yeah, it's out there.
I couldn't find it, introduction to mechanics.
Okay, so the best way to get to it is go to the calendar.
Yeah.
And then you take it off the calendar. Otherwise, to get to it, you gotta go into the site.
Yeah.
The Pearson site, and you can find it in there. So there's 2 ways to get to it.
Hey, somebody lost their wallet.
So, I wish I was an expert at it, but I'm come to determine I'm an expert.
Well, I did that Pearson introduction assignment.
Yeah.
And I couldn't find a check one to work assignment. I'll try to put it down.
Yeah, click that, because I did it so that it's on the 11th. I've made it, actually, I should have made it next week.
And I want to try to get it done ahead of time, so I don't have time. All right.
Okay.
Next.